Morning, everyone. Hey, how was your beer conf last night? Good? Yeah. Oh, coffee. There we go. How are we all this morning? Good? Not awake. Excellent. Hold on. There's no voice on that screen. Well, it's meant to come out of the speakers. Oh, apparently there's a delay on the sound over here, like a 3-second reverb or something. Oh, the TVs are on. Can we get that fixed? Everything's on fire this morning. It's fine, guys. It's fine. Wow, I can actually hear myself now that you mentioned that. All right. Let's just try and power on anyway while they fix that. So, second day of DConf. Now, before we get started, a few things that we should make a note of. Let me bring up my notes. Okay, so everybody, you're aware of your little tags here, right? And you got the security thing on the back. There has been a request to wear them name out, because not everybody knows everybody here. So this is their point of introduction. Oh, yeah, hi, I'm Ethan. Hey, excellent, cool. Also, for everybody playing at home, the YouTube stream is now working. Hello, YouTube. Woo! Okay, and now, speaking of our beer activities last night, there is somebody that left something behind. It's a valuable piece of equipment. I'm not sure where else you can get one like it, but there's a bag full of DConf stash. You've left it? Anyone? All right. Yeah. I mean, thanks for ruining my joke, Mike, but yeah, there is more than one. So, yeah. Stop leaving your stuff around. Take it with you. And if you did leave it, there's going to be a stash of them here. Just find it. All right. I think we're just about done now. So now that we've done that, we can get on with Francesco's talk. Francesco Gala, give him a round of applause.
Is this working? All right, can you hear me? Right. So this is the first time for me at DConf, and I'm quite excited. But what I want to report here was the experience of the Symmetry Atom of Code, which, wait a second. Okay, all right. Which took place the last autumn, obviously, from September to December, and involved 3 participants, of which 2 are here today, me and Francesco Mecca, which is sitting right there. And with the objective of improving the ecosystem. I don't like talking about me, but I'm a computer science student. I come from Italy, in Turin. I discovered D while I was trying to expand my experience and improve my knowledge. And I was coming from mainly a C background, so it was a nice discovery, so let's put it this way. And I was also looking forward to contribute to an open source code base, and I was quite interested in start contributing to D. So I discovered from Google Summer of Code Ideas page, which was 2019, which the D Language Foundation wasn't accepted, that there was this need of HTTP2 in Vibe.d. I don't know if you're familiar with, well, I guess you're familiar with Vibe.d. How many of you use Vibe.d regularly? How many of you are familiar with the Vibe.http module? All right, quite much. Nice. So there was this plan to rebuild the module, improving it, and in the meantime also include support for HTTP2. So how many of you are familiar with HTTP2? All right, for all the others, I've prepared a couple of slides which are going to be a quick introduction on that. So there are main differences between HTTP1 and HTTP2. The 4 main differences are here, but on a low level, implementation level, there are much more. So the first one is that the protocol is stateful, so you have to maintain a connection state. It is a binary protocol, which means that you have to serialize everything you send and deserialize everything you receive. And then it builds upon TCP to integrate flow control and multiplex various requests on a single TCP connection, which is quite important when coming from HTTP1, because with HTTP1 you have this, for each request you need to open a new TCP connection, and this caused many problems when scaling on a large number of requests. Anyway, this talk is meant to be a report and is structured in 3 parts. The first one being a description of my work schedule. The second one is an experience analysis from the point of view of a participant, which I think could be useful if you need to start contributing with a project such as Symmetry Atom of Code or Google Summer of Code. And the third one is a list of possible improvements which can be actually taught before a probable next edition of Symmetry Atom of Code. So I had to design some milestones which were monthly reports which I had to fill in order to like get paid for my work. And the 3 of them are here. There are 3 building blocks, which mainly are protocol switching from HTTP1 to HTTP2, the header completion algorithm, which I'm gonna describe later, but it's based on ranges, and it's meant to serialize the headers of each request so that they take a little space with respect to the HTTP1 headers. And then there's the asynchronous handling of HTTP2 streams, which are just are request and response cycles, which was built using Vibe.d asynchronous IO technology. So milestones, what are milestones? Were checkpoints. Each month I had to report to Mike, which is sitting back there, my progress, so that they could evaluate what we were doing and establish if the progress was actually, let's say, on par with what we defined on a previously submitted proposal. So the milestones were proposed by applicants, by us, which had to find a mentor and then discuss with them the possible strategy for the development of the process. So here comes the part of working with a mentor, which is, as at the beginning, some difficulties, as some benefits, but mainly my mentor was Sonke Ludwig, the maintainer of the Vibe.d repository, one of the maintainers actually, and we mainly talked about bugs found, about implementation issues, about high-level strategies, and we mainly talked using emails and GitHub PRs, since we weren't very fond of Slack, nobody of us. So one of the benefits of having a mentor when you start contributing to a project is that you can be followed. The main benefit is that you can be followed. The other benefit is that the constant communication flow, almost constant communication flow, can maintain focus, and I found this to be very helpful. Anyway, moving along, my workflow, I'm going very fast here because this is like needed for to explain what went on during the project. During September and October was mainly dedicated to studying and reading and studying and reading, and quite banging my head because I couldn't understand how Vibe.d core worked. I couldn't understand how HTTP2 worked, and I kept on going in circles and building my paper stack of things to do, which got like completely destroyed on a weekly basis. Then after a while, I started to wrap my head around it, and Song helped me with that a lot. And so I started with implementing the basic building blocks. The first of which was the HPAC header completion algorithm, which basically it's an Huffman encoding, slightly modified, which can be used to save and serialize headers as they are received, so that the next time you send a message on a request, they take less space with respect to the first time. This is supposed to be useful, and it's actually quite useful when you have a situation of a lot of requests which are coming sequentially and from the same origin, which it's actually quite often the case. From November to December, I had to devise a strategy to implement HTTP streams, which are request and response lifecycle. So a stream is composed of one request, one response, and all of this happens on the same TCP connection and can be multiplexed with other streams, which means other request and response. The particular thing here is that HTTP2 uses data dispatch mechanism, for which there are separate, it's called frames, but it's a note. If I'm confusing here, you can raise your hand and ask, because I know I decided not to dig too deep on how HTTP2 worked, but I guess it can be pretty confusing from a listener point of view. Anyway, there was a lot of testing and bug fixing and testing and bug fixing going on, and we uses the asynchronous I/O capabilities of Vibe, which are based on tasks. I don't know if you're familiar with tasks, but are basically fibers or green threads, and to implement an efficient strategy, which I'm going to describe further. From December to January, and what is being pursued right now, because we're still working on it, is to complete the review of the last part of the project, because Sonk and I had our commitments to attend to, so it kind of got delayed, but it's there. And then there's some profiling to do and some other testing, some other bug fixing, testing and bug fixing. My point being, after this whole month, when the first time I was able to send a request to the web server and obtain a response, my reaction was this. and I felt like Frankenstein Jr.'s doctor for a while. But the point is, it's really alive, and it's there, and it can be tested. It's on the Vibe/HTTP experimental module, which the plan is to introduce as soon as everything has been ported to HTTP2 capabilities. And so, how does it work? It works pretty much transparently with respect to the previously available HTTP module. In the sense that if you are using Vibe HTTP for HTTP1, the support of HTTP2 comes at no cost of reimplementing anything. Simply, if you receive a request to upgrade to protocol using protocol switching to HTTP2, the flow you need the code you need to write to initialize a web server is the same. If you're using TLS, this is the only line you need to change, because for TLS we are using application layer protocol switching, which is one of the capabilities of the SSL and TLS suites, which allow to negotiate a protocol at the session layer instead of the application layer, talking in Aussie layers. The HPAC module, which is something we are pretty much proud of, is a simple interface of two methods which can be used and are based on ranges. So we are using exceptions right now, so it's not no GC for that reason, but it could be, because all the dynamic memory allocation have been pushed out of the module. It's very lightweight because it uses memory resources. We are following the approach of other web servers, as one of them is Nginx, which is using a static table, quite big, like 3,000 lines of code, and to be more lightweight on CPU and memory, which avoids mainly the possibility of denial of service attacks, which is something that has been explored for HTTP2. HTTP2 message exchanges work by handling multiple HTTP requests, so over the same TCP connection. So that's one great step with respect to HTTP1, and something that needs actually it needs improvement right now, but it's working pretty well. We can comply with flow control restrictions, which are mainly restraints you can put on how much data you can send as a web server. So if my web client asks me, you can send me 800 kilobytes at most, I have to send him at most 800 kilobytes, and then I have to wait until he sends me another message telling me, hey, you can send me another 800 kilobytes. And we can comply with that, which was not easy, but we have done it. And then we are working on enforcing protocol correctness, because the RFC, which describes HTTP2, actually leaves most of the implementation details quite open. So we have means of defining priority between requests, priority between connections, which are actually not described. It's just written there. You know, they tell you, you can define priority if you want, but everyone uses their own approach. So we are working on defining those parts. And what is missing is mainly the last review of stream multiplexing and flow control, which is this actually, and server push, which is a feature, an optional feature, an additional feature, which was introduced in HTTP2 to allow for a server to send data to a client without having received a previous request. This is quite controversial, but we decided to postpone just because it wasn't part of the actual implementation. And then there's testing, bug fixing, testing, bug fixing. So if anybody wants to help with that, we'll be very glad. A quick rundown of some of the interesting parts, which are not that much technical because this is not a technical presentation, but we use the ranges as a serialization interface, and they are one of the reasons why I think D was great for implementing a network protocol, because ranges allows us to provide a powerful abstraction and write a module which is seamlessly integrates with all the other stream data structure which are part of Vibe.d. And we can support custom allocators, which means you don't have to depend on the garbage collector. You can use your own allocators. We have everything templatized on input ranges and output ranges, so you can use this module as a standalone module outside of the Vibe HTTP module if you need to have an HPAC implementation for your own web server. And this is quite easy, as can be seen here, because you just need to provide an encoded source and a destination, which in our case are a U-byte stream, a U-byte range, and the structure which describes the HTTP frame header. And there you need simply to provide your table, which is the table I was telling you before, the one which is encoding all the possible requests, and your allocator if you want to use some. I've talked about metaprogramming. This is very far from the metaprogramming which, for example, Robert told us about when he was telling about writing code that generates code. But we exploited some of the features of D to create the indexing table, which is a hash table, which changes both a static table, which is initialized generated at compile time, and a dynamic table, which is built around a ring buffer, and all that while providing a unified interface. So you see we have a static table, a dynamic table, which is supposed to change during the execution because it's supposed to store what has been received. Like in the we're talking about headers, so header name and header values, and those headers are made of name and abstract data type, algebraic data type key, which is made of integers, U-byte, or string, according to the type of header. this was pretty illuminating to implement, just because it allowed us to keep the lines of code to a minimum while providing something which is quite safe to work with, and in which it's quite easy to spot bugs. As you see, we use the same idea which is behind the chain in when we were talking about std.range, which is we provide a unified address space while concatenating two of the table according to the index which is provided. So we have all the operator overloading to treat this as an hash table or a range. We used concurrency in a way to exploit the asynchronous I/O model, and we support message passing between tasks. But we built this architecture for the HTTP module, which is made of the event loop, the vibe.the-event loop, which for each connection spawns a task using run task, and passes everything along with the frame header to an HTTP connection handler. This then goes to the stream multiplexer, which is supposed to tell us, is this stream valid? So can I receive the request? Can this request respect the flow control scheme I've agreed with my client, and so on? And if that's true, we have the request handler, which is going to build a response and send the other's response, and then spawn another task, which is gonna dispatch all the data which is needed for the request, which can be an HTML web page, a CSS asset, an image, a PNG image, or whichever you want. And it's going to do that in chunk, because those chunks are what allows us to respect the flow control. As I told you, if I know I can send 800 kilobytes and I have to send more than that, I have to split my data in chunk, then wait after I send the first chunk for the peer to send me another request, which tells me, hey, you can send me another pack of data. And in the meantime, I have to yield control to the event loop. So all this is built asynchronously. And that was what we did. And I can provide more details on that. But I want to focus on the experience analysis, because I think it's important to analyze what went on from the point of view of a participant, so that maybe future participant can benefit from that, and from the point of view of the community as a whole, to see what we can improve on this experience. So if I want to start contributing, and this is very related to what Sebastian talked about yesterday, if I want to start contributing and I see that the symmetry out of code announcement, why should I participate to that? I could participate because it's a great occasion to learn. I could participate because it's easier to start when you have a mentor and when you're followed, and it's easier to gain insight about the dynamics of an open source community, because you get to write to people which are inside it, you get to communicate with them and exchange opinion in a much easier way. All of that while being paid, which is a point I have to make, obviously. So if you wish to start as a contributor and you have one of the following issues with that, so you can decide what to work on and you don't know maybe who to talk to, because you don't know who's in charge of the various projects inside the ecosystem, or maybe you have no experience and you're afraid of not completing your work, there are some things you can do which can help you a lot. The first one is that if you can decide what to work on, you can just go to the D-Lang wiki pages and gather some ideas from there. They list a series of possible useful projects. And for example, mine was on the GSOC 2018 ideas page. And for each project, there should be a mentor assigned. And I think this can actually be improved, and we're going to talk about that. But it's a great starting point. If you don't know who to talk to, there are the many communication channels, and I have an edit there after the Sebastian's talk because he can explain it way better than I did. But you can post on the D forum, you can ask on IRC or Slack if you prefer Slack. You can write a simple proposal and send it to someone and say, hey, I want to start contributing. And where should I start? Sonke Ludwig actually did it for me, and it was very, very nice to talk with. And the third issue you can have is that if it's the third time of your first time, sorry, of tackling a huge project, you might not know where to start, and you might have little understanding of it. So I don't know when to start from documenting myself. I don't know where to start from understanding the internal logic, but also the development process. And this is why there's a lot of time to be spent reading at the beginning. At least it was for me. So my first message is never be afraid of reading, actually. And in my case, I had to read a lot of stuff because the RFC are quite long and can be quite frustrating. But it's quite easy to wrap your head around the project. There's pretty much well-documented code on Phobos, except for maybe some modules, but it's not a topic for this talk. And also for Byte.d, there's pretty much of documentation online from their website. And then there are similar projects which one can turn to. For example, in my case, I can have a look of other web servers implementation and reason about their strategies to, let's say, take hints. And then there's the community itself, which is pretty useful in that regard. Then there's mentoring, and mentoring is the key when you want to kick off your experience and start with a good rhythm, you know, because as it was the case from this year, one of the participants found some difficulties which he couldn't cope with, and he had to leave. He also had less mentoring help because his mentor was found later because of a turn of events. So one thing you could do if one situation like this come to be is communicate and let your needs be heard. So going with notes from the future, which I think are the most important part of this talk, these are geared towards the community, because when I come to reason with the help of Francesco, which is sitting right there, about what our experience was and how it was organized, how it was planned, we decided that it could be improved in some ways. So we know we have some benefits. We know we can spread the usage. We can push development of the features using a project like Symmetry Atom of Code for the simple reason that it brings new people inside the community. We know that if you have a fresh eye on a code base, it would probably find a new perspective on it. So fresh eyes and minds might solve bugs, which is something which shouldn't be overlooked. And as I said, there are benefits to that, both from the participant point of view, then to the community members' point of view and the foundation point of view. But there are risks, because in a project such as Symmetry Atom of Code, if it could happen that participants drop early and don't finish the project, and that's a waste of resources mainly, and a pity actually. It might happen that the work which was planned in advance might require more time than what was decided to be. So, for example, in my case, I have to say I'm a little late. Yes, I am, because the milestone review which we had to complete for the beginning of this year is still going on, and that is not due to us, than to all the commitments that the mentor had, I had, and I guess it's not easy to plan in advance those things. Also, we have the introduction of new feature with the Symmetry Atom of Code or Google Summer of Code projects, such as HTTP2, which have a risk to be orphaned If the participants decide to leave after the experience because they did their work and they got their money and they're running with it, maybe, or simply they get tired and they're not satisfied with the experience, it might happen that the new features are left there. There are quite some examples of this. Well, one of that, I think it's the XML module on std.experimental. So how can we improve that? We could build something like a desert switch, but that's not the point. The point is that we have to do, in my opinion, 3 things. We have to increase communication a little bit. We have to improve means of gathering of ideas, especially because sometimes the wiki pages are not sufficient, sometimes they're not updated, sometimes they're not what we, they're not all that could be. And we have to determine if and when an actual project comparison between the participants is needed. So, communication issues. We didn't have much communication issues, but it is true that there were few of us. We were 3, then we came to be 2, and but we saw that if one mentor decides to be busy 1 month, this can cause delays on milestones, and also if the participant has some other schedule for that month, this can cause delays. And if a participant is in need of help because his mentor cannot help him, or maybe it's he cannot provide all the knowledge he needs to use, there's the need to someone. And one thing we can do about this is to encourage participants to document their progress, so that other people can jump in and help them, knowing whatever they did in the previous months or days or weeks of work. To quantify an impact of a project for a participant is also quite difficult because, for example, in my case, I don't know which impact it's going to have on the community. I mean, HTTP2 is quite useful if you have a large number of requests on a, let's say, enterprise-grade web server, which needs to serve heavy content. So lots of cookies, a lot of dynamic web pages, which exploit the multiplexing over a single TCP connection, exploit the fact that you can control every little bit of what is sent and is received. But if you have, let's say, a static web page, a blog, maybe, it's not that useful. So what's the impact it's going to have on the community? I guess that is to be seen. But if with proper communication and with proper reporting, maybe on, I don't know, on the forum, on the IRC channels, of what is being done, maybe the community can provide more insights and more advices about what has been made and what is there to do. Another thing is about encouraging to post on the forum. We weren't really encouraged to do that. We weren't neither forced to do that, and I have to say I didn't do that, and I regret it. I should have made my progress more clear, maybe, just because it could be useful. It could have been useful to have some more insights about what we were doing. And I'm gonna publish with Mike a blog post about this, and so that we can discuss it more. But the aim of it is that participants might need to be motivated, and not just through the money or the fact that they are contributing to an open source project, but through the fact that their project seems and actually is useful. And sometimes I think they need to understand that from the community directly. The other thing I wish to concentrate about is that fostering ideas from the community is not that clear if we're coming from outside the community. Like, we have a series of dlang.org, wiki.dlang.org pages which kind of left unmaintained. Like, I don't know, we have project ideas, which is there, and it's been there for a long time, but I feel like nobody is looking after it anymore. We have a wish list, and if I'm coming from the outside and I say the wish list, I might think, hey, something in there is useful. something is there needs my help. But then the last history commit is was 2015, so I guess that may not be updated. There are the language design discussions, which also are quite past our time, and there are a lot of projects which could be updated, could be removed, or I don't know. For example, let's take Calypso. Calypso is at a development stage which is way further what is described on the wiki, and I think this is about who's working on. It's an objective of who's working on Calypso to update the LangWiki, but nevertheless, this may lower the quality of the information we have there. And this could also make other pages seem less, I don't know, worth of trust when you're deciding what to do and how to do it. So my suggestion here, and it's something which can be worked on, is to put some effort in maintaining one reference page, which can be periodically refreshed and cleansed of new ideas and old ideas. Can be easily reachable from the dlang.org website, because you don't want someone who wishes to contribute to have to navigate through the whole wiki to find that. With the objective of making contributors autonomous, so that they want to propose an application for the Symmetry Atom of Code or the Google Summer of Code, they simply have to say, oh, there's this page, I go here, and I check the mentor, which is associated with a proposal. It might not be a mentor, it might be a maintainer, it might be someone who's responsible for that, it doesn't matter. But I think it could be very useful as a reference for planned and desired work which is needed in the community. Then there's the last point I wish to make, and I don't know, how am I on time? Can you give me ahead of time? Thank you. So the last point I wish to make is that project comparison can be difficult. We found ourselves in the situation in which one of us was to be awarded winner of the Symmetry Atom of Code project, and our first reaction, at least my first reaction, was winner for what? And because our projects were different, he worked on a garbage collector, I work on an application level protocol, because we designed our milestone. So we decided how to work and when to work on it. We communicate in different ways and with different frequencies, and add some kind of different development process. Mine was mainly write code, then submit a pull request, and then Sonke would tell me, oh no, you can't do that, you better do that other thing. And there was this review cycle which took a bit for each milestone and pull request, and there were about 15, 16 pull requests submitted of my side. So while Francesco, and I'm sure he can explain it better than I did, but Francesco has a lot of email exchanges and very few pull requests open, because it's his code base and his changes he has to submit was way less than what I had to submit. Anyway, how can we judge two different projects? And it's something, it was not very clear to me, and it's not very clear. It wasn't very clear at the presentation of the Symmetry Out of Code either. So we have to base on some objectively measurable quantity, which can be how many lines of code have been written, or how many pull requests have been submitted, how much he posted on the forum, or he or she posted on the forum, how much he exchanged emails. And so I gather some data, we gather some data, and well, this is what Francesco's did to make you understand that the difference between my work and his. He can explain it better than I can do, but he had to study a lot, he had to design a lot, and the point of this, he had to work less code than I did, but it surely took him more time to write that code. So, as you can see, we have two main differences there, which is that he exchanged a lot of emails while I exchanged very few. He wrote very few lines of code with respect to mine, but I think it can be said that I wrote very few lines of code too. And when I realized that this data was actually telling nothing, I I told myself, well, I cannot measure I cannot compare two projects like that because there are different, and there's a balance in which you have to work on. For that, if I have my project, my actual implementation time required and mental overhead and such was way heavier than the time spent discussing it, because I have everything laid down on an RFC. I had a whole lot of documentation. Well, if you have to work on the runtime or something low level, it turns out that the actual implementation time, it's way less than what you have to put in discussion, in design, in benchmarks, and after that, maybe profiling and considering if your contribution can be integrated properly. So what's the point? What's the point in comparing two projects? And I tried to reason about that, and I think that's a point that needs discussion. What's the point if you want, the point, possible aims could be to strengthen competition so that each participant works more. And they work more because they want to win something. They want to win something, and they want to be awarded to be the best. But is it actually needed for project completion? I mean, if you are, from the point of view of the community, you want something like this because, in my personal opinion, at least, you can introduce changes and you can introduce new people inside it, and changes which can be used, which are useful and solid, or become solid with time, actually. But none of the competition that could be enforced is geared toward project completion. To me, it's all about careful planning of what work has to be done, to ensuring mentors are available and willing, but I guess we have plenty of them, fortunately, and to consider interest and proposals over technical preparation, because that might not be a requirement. But the most important thing for me was that participants must document what they do, because it might be that the work they did gets lost because they did it their own way, because nobody else is going to pick it up after they finished, and because they maybe don't have the time or the resources to finish. So I think one of the possible improvement is not necessary to enforce competition between participants, but it could be that enforced documenting and reporting and a little more planning time could benefit the project completion. So to conclude, because I think I'm almost out of time. All right. Symmetry Atom of Code has been a great occasion for me, because I can be here and it's very exciting and it's the first time. So, by the way, sorry about my English. No, it's not that bad. But and it can be an approach to starting as a contributor, which is an alternative to doing all the work by yourself, which can be tedious, can be difficult, and sometimes it's just better to be followed on the first steps. But it needs more guarantees, in my opinion, that the work we did is useful and that it can be used and exploited after the project finishes. So, thank you. If you have any questions, I'm pretty happy.
All right, so raise your hand if you got a question, anyone. There we go. First question. All right, Sebastian's on it.
About your Vibe HTTP implementation, is there a plan? Is there a plan how to implement the HTTP to push API?
Yeah, as I said, there's a plan, but we decided to postpone it because mainly because it's not actually necessary for the correct function of the web server. So if you need to focus on something right now, is to complete an efficient strategy for stream multiplexing, and then maybe to implement a proper way of deliver large files, which are another part of the issue. After that, we are planning to work on that because we saw that there's a lot of requests and desire for that feature in particular. So it's gonna be there. It's just I cannot give you an ATA on that at the moment.
Cool. Anybody else?
I had my breakfast. I don't bite.
All right, questions going once, going twice, 3 times, that's it. Give it up again for Francesco. All right, before we have a little break, you may have noticed we've had a bit of a schedule shuffle. The updated time slots are available on the announce forums and the D-Lang website. Go check it out if you want to know what's going on. Otherwise, back here at 10 a.m. for the next talk. We're back, we're all sitting down. Okay. Oh, there they go, off to their seats. Hello. All right, there's a rather involved discussion up there with Walter and Andre and everybody. We're about to start again, guys.
Okay. I just want to note I still only have 1 monitor available. Is that correct?
Oh, you should have. Well, that's all up to your display there. Like, you should be able to get that.
Right. But I'm saying I'm just seeing 1 HDMI output. Is that correct?
1 HDMI output. Yeah, that's fine.
All right,
Yeah,
because
these
I thought those were separate.
Yeah, no, this monitor, and that monitor match.
Oh, okay.
Yeah.
All right.
All right, we've got
gonna be a
those
bit
little
interesting.
issues sorted out now, I guess, and we're almost ready to go. Yes. Okay, everybody, it's on time. Hooray. And over here is Matasphere. Take it away. Applause, applause.
Thank you. Almost got the name right. It's all right. Hello, welcome to DConf, which is kind of a silly thing to say on the second day. Excuse me. I'm a bit nervous. I'm going to be talking about the way that we develop software at Funkwerk. We've been writing D-based software for coming on 10 years now, and I like to think we have gathered some experience with the not exactly optimal, with a rather effective way to combine the features that D offers into a development approach that is appropriate for writing sort of a semi-microservice-based architecture without running into the plentiful pitfalls that D offers when you're going in the route of long-running services. First of all, a bit of introduction about what exactly is Funkwerk, who exactly are we as a company. A lot of you arrived here oh, I'm sorry, I'm standing in the way. Apparently, I'm being told. A lot of you arrived here by train or by tram or by underground rail, and you may have seen an announcement that a certain train was delayed a few minutes because it missed the last station, or five stations ago, it got a bit of a blocker on the rails, and it can't be there in time, so you have to take the replacement bus. That is what we do essentially. The entire chain of data flow in this, from the point where the train measures that it's delayed, from the point where it doesn't realize, where the station realizes that the train hasn't arrived yet, to the point where you can actually see that information on the display. This is passenger information, and this is our competency. So usually it is not the case that we control the entire chain of data flow from train to display. Usually it's the case that the customer has their own sensors at the train station, or the customer has their own displays. And so we need to speak with one in a rather large variety of possible protocols. And so in that sense, basically our job comes down to taking in data either directly from the device or from one of a large number of interesting and hilariously outdated protocols, and transforming it into a unified internal domain format, doing some processing on it and handing it out again in the format that the customer expects and that the display expects. So for 10 years, approximately coming on 10 years now, every new backend component in this chain that we've written has been in D, largely D2. So this started out in a place where we were coming from Java, essentially. Rather, we were basically, we weren't entirely comfortable with this new language yet. And we wanted to be sure that if it turned out that D was actually secretly really terrible, that we wanted to be able to switch back to Java or switch back to something similar. So our initial code was really, really Java-like. So to the extent that we actually generated classes from a UML template, so we could potentially switch straight back to Java if need be. This was not a good idea, even at the time. Basically, if you're having a very long-running service and you're reading gigabytes of XML of external data, and you have to parse that, and you have to transform that into an internal format, and every single XML node is a class, and all of them reference the class above them and reference the children below them. Let me put it like that, we bought a lot of memory. It was definitely not unusual to see processes in the single or very low double-digit percentages of gigabyte. Furthermore, rather demonstrating the point that from the start, classes should really have been non-nullable by default. Every single member of these classes had an invariant that checked if they were not null. If we had a constructor, we checked parameters if they were not null and start. If we had a function, an accessor, we checked if the result was not. There was a lot of boilerplate going around. The further problem is that what we ended up with is already we were trying to go for a microservice architecture. Like we didn't want a monolithic heap of code. We wanted something where you could work on different components at different times in different teams. The problem is that we were still extremely stateful. Like every time one of those components started up, it had to talk with the services that was trying to interact with, and it had to get to bootstrap its state from these services. And there was a lot of bootstrapping involved. It is not unusual, even now, for a starting service to take half an hour. That's not good. It's really not good, especially if you're supposed to be agile. Furthermore, we ran into a problem that we really didn't use in significant amounts of const yet, primarily because, again, coming from Java, there's no const in Java. So we had a lot of distributed code that changed state in a lot of different locations. It was not easy to understand what that code was doing at times. So over the past 10 years, we've tried to gradually switch to a sort of proper, better style of doing things. And I'm going to have these slides in the talk with the exclamation mark. Those are my rant slides. Sorry, my respectful criticism slides. I'm trying to give some pain points that we experienced and really highlight where I think that D could be better. Now, when I'm saying D is almost too powerful, that seems like praising with faint damnation, essentially. And this is like, powerful is good, right? A powerful language is something you want. The problem is that D is so powerful and D is so generic that you can write D in a C style. You can write D in a Java style. You can write D in a C# style, even if you want. The problem is that if you write D in a Java style, you're going to suffer, essentially. You're going to run into difficulties, and these difficulties are only going to reveal themselves after you have already invested a potentially very large amount of time in writing in this style. In that sense, specifically if you're running with, like we did, Java like D with long-running processes, the garbage collector, especially on 32-bit where we started out, is going to hurt. Now, the thing is, it doesn't have to be this way. Like there's good D in the sense not that it's good code, but in the specific sense that it works with the advantages and disadvantages that D has, that it avoids the pain points. And furthermore, this is also D that looks good. This is also, if you're using ranges, if you're used to using ranges, this functional style, it's very elegant, very impressive. And I think specifically, there's a code style guideline for D, but there is no development style guideline for D. Like there's no sense that if you look at the documentation, there's no sense in general of the pain points. Like there are open bugs in the language that have been open for many years that are completely undocumented in the documentation. In a certain sense, the documentation likes to pretend that everything is all right. I think that's a mistake. I think specifically the documentation could say this is a weak area. If you want to be safe, you want to write long-running process, you could avoid this. You should write it in this or that sense, this way instead. Like push structs, push ranges, push no GC. Especially if you're having developers coming from Java, this is not obvious. This is very much not obvious, and I think it could stand to be documented a lot better than it is. Coming back to our problem. So we actually have a dedicated architect, and this dedicated architect had read recently about domain-driven design. And this was a very good thing for us, because domain-driven design is an architecture that really synergizes well with D. Now, the problems that we ran into were the plentiful use of global state. And the thing that we did to address this was we tried to very much compress state into a small number of objects. and a small number of classes in particular. So one way you can do that is you can try to write your code in a way so that it's impossible to change state, or that it's impossible to have idioms that change state, except in specific points of code. You want to concentrate your state changes in a smaller layer of code as possible. Furthermore, we've tried to split our code apart into areas of competency, into going by which domain area this code was relevant to, and then actually do hard enforcement of the separation between those layers. The way that this works is, oh, there was supposed to be text in there. Okay, we have some additional font problems. It doesn't matter. No, it's good. It's good. Okay, so this works. This is pure domain-driven design. The idea of it is that fundamentally you're splitting code approximately in 3 layers. So you have the protocol layer, which concerns itself with the interactions in between services and the outside. Basically, every time you have 2 services talking to one another, or one service talking to the network or talking to a customer, this is protocol. Control is state change. Every algorithm, every state change is on the control layer. And model, which is a bit weird, is just your domain. Like, the definition of the data in your domain is in the model layer. And the model layer is a lot more important than you give it credit for. I'm going to go into that in a bit. The important part is that protocol can see everything, control can see model can't see anything else. Model is pure. It's isolated. And furthermore, usually when you're talking between domains, we don't have that completely internally, but usually you only want data flow in one direction. Basically, when you're looking at this area of code down here, when you're looking at model, you don't want to have to think about anything else. You don't want it to be possible to think about control. You don't want it to be possible to think about protocol. So this is actually hard enforced in our system. We're using the depend library, which one of our developers has written. And this is a framework where you can actually, well, the ostensible purpose of it is to generate UML diagrams of package dependencies in D. But the beneficial aspect of this is that you actually have to specify your dependencies up front. And when your project violates the dependencies, you get a very nice audit error in your build system, in your, And you actually get warned, and you have to explicitly opt in to any dependency that isn't already specified. Right. So these 3 layers I mentioned are important because they're different. Like, if you're looking at the code in those layers, it's completely different code. There's almost no similarity. And just a sketch. Okay, at the protocol layer, you have state, but all the state is state from your framework. For instance, you have HTTP state, you have JSON RPC state, you have whatever XML, JSON, XML RPC state. There's a bunch of options there, but you don't have application state. You don't have anything about your domain. For those who don't know domain-driven development, I want to throw in here for a moment that the domain is everything that is business logic. Basically, when you're talking about trains, you're talking about domain. When you're talking about requests, you're talking protocol. So in the control layer, the second one, this is every bit of domain logic, every bit of business logic is concentrated here. And specifically what it does is all the state changes, all the algorithms on this layer. And the model is pure. The model is stateless, which means that nothing in the model mutates anything. Nothing in the model holds any state. The model describes state, but it doesn't mutate it. What this comes down to in D in practice is specifically at the protocol layer, we are taking heavy advantage of templated, boilerplated code. As this leads to something called a naming protocol. I'm tentatively calling a naming protocol. Basically, in an internal service, it doesn't have to talk to anything complicated. It just has to talk to other services in the same architecture. Protocol is basically empty. It's just code that says, I'm connecting to a server on this domain, this port, and it implements this interface, and that's it. All the rest is generated. All the rest is framework code that you don't have to write, you don't have to worry about. Now, the thing at the control layer, I'm just sketching this right quick, is at this point, because all the mutation is concentrated here, and because you don't need the protocol to set this up, control is isolated from above. Again, I want to clarify this. In a usual service, if control needs to send a message to another service, it has to do a protocol call. It has to say something like do an HTTP request to that service. We don't do that. We don't talk about HTTP in the control layer. This is basically, we're using something called dependency inversion, where the control layer specifies what sort of calls it wants to be able to make. And it usually does that in form of a class. And this is essentially the only place where we use classes. Basically, the control layer says something like, I want to make a request of this domain. And it does that by specifying an interface with a method. and then the protocol layer implements that interface, because again, the protocol layer can see control. Control can't see protocol. The protocol layer implements that interface and then passes it in when it instantiates the control structure, which makes it very easy to write feature tests because your tests don't have to worry about the networking. They can't worry about the networking. Now, at the model layer, this code again looks completely different. We have essentially only structs and enums down here. Basically, this is effectively plain old data. We wish it was plain old. It isn't plain old data, but it's effectively plain old data structs. That is structs that have no private state. They're semantically immutable. I wish, again, they use the keyword mutable, but they can't for reasons I'll get into. And they heavily use disable this. Everything down here is domain state. So disable this allows us to avoid it even being possible to create a struct that doesn't fulfill its invariant. Right. Oh, that's the wrong direction. All right. Now I'm going to have a bit of a rant here about structs as value objects. Now what we want is immutable. What we really, really want is to be able to say nothing in here can change state. You can only return a new value. You can't mutate anything, especially because everything in those structs could be public. We want it to be public. We want the domain level to be transparent because we're not hiding anything down here. The problem with immutable is that it doesn't work. It doesn't work with reduce, with group, and most importantly, it does not work with associative arrays. Associative arrays are the single most useful data structure if you're writing domain logic. You need associative arrays, but you can't have them. Because associative arrays have to do assignment to a key under the same name, potentially in the same data, and if you're using immutable data, nope, can't do that. You should be able to do it, but you can't do it. So essentially, with that single inadequacy alone, immutable has become completely unusable for us. So what we thought about this problem. And we said we don't actually care about data immutability. What we care about is semantic immutability. We care about that you can't construct a value as a struct and then you mutate it, then you make a change. So what we actually used was private, which goes against the entire point of the model layer. You want everything in there to be transparent. So what we're doing is we have private fields, and in every assignment, in every instantiation of a struct, every array that goes into a private field is stubbed. Remember how you complained about the garbage collector? Yeah. Okay, this was not nice, but it was necessary. Every time you read from such a field, and it's not a const read, it's not declared const, it has to be dubbed. So again, you have effectively an immutable field. You can't mutate it from the outside. You can't mess with it. You can't break it. The other branch of this is that we're using a lot of invariants to encode like business dependencies, something like a train, the journey between stations has to contain at least one station, stuff like that. And again, this is enforced by the fact that you can't mutate data in the structs, even though it's not invariant. We don't like this, but we have to do it. So here's an example for how this code actually ends up looking. Now, this used to be quite painful. What we used to be able to have to do is we have to private int array underscore, private array, and then we'd write an accessor for it. We would do public array of int array, and make it const, return this array underscore dub. This was horrible. So luckily what we changed to was this rather elegant, if I may say so myself, which I may not because it's my code. It's very improper to say that. It's UDA, very user-defined annotation, which basically just says generate me an accessor. And later on, generate me a constructor, and generate me a toString, and generate me an op-compare. Everything of this is abstracted away. You basically just have to tell the system what sort of automatic methods you want in there, and they're provided for you, which is convenient. So basically, using the information, the constructor generate this doesn't just generate a constructor. It also generates information that says what sort of fields this struct needs to be instantiated with and what sort of field can access. So essentially, we're taking the struct and we're making its members private, and then we're doing workarounds to make them public again. It's a bit silly, but it works. Certainly compared to mutable, it actually does the job. Right, I already mentioned a bunch of that, so it's going to be quick to get through here. The huge advantage of having protocol as a separate step, as a separate wrapper around the entire domain logic, is that you can swap it out easily. Like we're using REST calls now. We didn't used to use REST calls. We used to use largely JSON RPC calls on standing connections. And switching from JSON RPC to REST was easy. It was very easy. Like if we had written our domain code embedded in a protocol where you'd actually explicitly make REST calls or explicitly make HTTP calls, you'd have to change all of that and you have to solve all of that around. It would have been painful. Due to the fact that control is a thin wrapper outside it, a protocol is a thin wrapper outside protocol, switching to REST was very much easier than it would have been in a more embedded protocol. More embedded framework, I'm sorry. Now, here's actually a huge advantage that is not obvious. The fact that all our model data is transparent. That is, you can enumerate the public fields, you can enumerate all the properties, and you can see their types, you can read them. The advantage of this is that if you have some domain data that needs to be passed to another service, all of this can be generated. All of this is generated. You just call it on the protocol layer, just call encode with your value, and it's automatically converted to very, very trivial JSON. And again, because it's structs, you don't get into problems with loops, you don't get any sort of recursive data structure issues. You just get a very, very clean JSON format that you can just dump on the network and decode back. Now, a huge point of this is that we don't use classes in model. But there's one use case where you traditionally use classes, and it's when you have a field that wants to be one of a set of data types. Essentially what you would traditionally use the visitor pattern for. Don't use the visitor, please don't use the visitor pattern for domain data. It's bad, it's wrong. What you want to be using is, not sure if I remember this, algebraic data types, right? Where you want to be able to say, like, I have one of 5 different types, and I want to have one type that encapsulates all of them. Because the entire point, again, what's the point of OOP, of subtyping as compared to composition? It's that you don't know what your types are going to be. You don't know what elements are going to be going into this possible set of data. But in this case, with the visitor pattern, then you say, yes, I do know. Yes, I do know. It's this, this, and this. And I want you as a visitor to be able to be called with all of them. You're essentially turning back around. You're saying, I'm going to take this one advantage of object-oriented programming. I'm going to throw it away. I'm going to discard it. That's pointless. It's silly. Don't do it. What you instead want to do is you want to specify, I have this type, I have this type, I have this type, and then I have a composite type that can be one of each of them. Right, just small side trick there. Going back to the actual talk, at the control layer, this is where the main point of this talk comes into play. When I said process-based object orientation, what I specifically mean is that at the control layer, we don't use classes to model state. Or specifically, you don't use classes to model business entities. We use classes to model business processes. What I mean by this is that when you're asking a question like, when is the train going to arrive at a station? You don't have a class for the train. The train is a struct. You don't have a class for the station. The station is a struct. Because this is all limited state. What you have a class for is the question, like the analysis of trains at stations. Train station state, for instance. The advantage of this is that you're using very thin layers of object orientation. The only reason to use object orientation here at all is to abstract in between domain slices. For instance, if you have protocol A on the left side, protocol B on the left side, you only want to specify an interface of these sort of questions you want to ask of a station, and then on the other side you just inherit that, and the protocol layer puts it all together into an application structure. So you just worry in each slice about the sort of, you implement the sort of APIs that the other parts of your program may be interested in. The advantage of this is that there are very few points where state can change. State can only change in the process classes. So your threading becomes very simple. Your synchronization becomes very simple because you only have to synchronize at those points where state can change, and those points are just the process classes. Essentially, we are not afraid of threading. Usually, we have a lot of threads going around, and we have a lot more deadlocks than we have corruption issues. We have basically not had any significant corruption issues for coming on a year now, as far as I can remember, because it is very easy to avoid corruption with this model because you're not changing anything except on those 1 or 2 points which are wrapped in synchronized blocks. Cheers. Right, I think I already said that. Right, and a useful side effect of this, another useful side effect is that at the control layer, you basically have those few classes that implement the requirements that you're exposing to other layers or to other slices of your domain. and everything else is functional code. Like, this lets you use ranges very, very, very heavily. We basically use ranges exclusively. There's our designer once said, I think every for each is a bug, and he reviews with that in mind. If you're writing a loop, he slaps you on the hand. It's like, why are you using a loop? Use an each, use a map. It's actually really good because you're avoiding a lot of possible bugs that way. Basically, every time you would usually get into inconsistencies in your data flow, you usually get a compiler error instead. It's very nice. It's actually surprisingly memory efficient too, because surprisingly many range operations don't actually allocate memory. You'd think that functional programming would run into memory problems, would run into uncontrolled allocation problems. It's actually much cleaner because you don't have to create arrays all the time. You don't have to create appenders all the time. You can just build up your transformation, and you can say, okay, just crank it. Just crank this chain of ranges, and you'll be happy. You get your data out at the end, and then you create your new state, create a new model state, and you can synchronize in one go. Makes testing easier too. Apropos synchronization, time for another rant. Synchronized is a good idea. It's a very nice feature. The idea is you have a class, and you can just mark it with synchronized class. And what this does is basically every method is synchronized, and every public method is synchronized. And when you call the method, you automatically grab a mutex, and you do all your invariant checks, and then you go into the main code, and this is shared. Why is it shared? We don't know, because the problem with this is the idea of shared is that you're looking at data that may be in view from multiple threads uncontrolledly, essentially. And everything that is not directly under this, that is referenced, for instance, arrays, has to be shared in the current D approach, because maybe this is this array that was passed in from another thread. Maybe the other thread is going to mutate it. You don't know. You can't know. The problem with that is we don't want shared. We really don't want shared because it doesn't do anything. Shared is at the moment pointless. What it does is it's a semantic annotation. It just says this code may be visible from other threads. You should think about it, and you have to say, all right, I thought about it. It's not visible. I'm going to cast that away. We don't want you to use cast. Cast is a sign that the compiler hasn't understood what we're doing. Cast is a sign that the compiler, we don't trust the compiler. The compiler says you can't do that. We say, yeah, I know, compiler. I want to do it. It's okay. It's okay. But that's not good. That's not good because you don't get checks. You're losing all your checks. You're using all your type checks. You're losing all your constancy checks. If you're casting to another type and you're casting away shared, but you're also casting away immutable, for instance, and you don't notice it, the compiler doesn't tell you. It can't tell you. So we don't want shared. We don't. On this one case alone, we've basically eschewed the use of synchronized classes, but we still needed synchronization. So every single control class that changes state has methods using synchronized this. The problem is now our invariants are completely boned. It's hopeless. It's completely hopeless. Let me give you an example. So this is how you would technically have to write code if you wanted to synchronize this in a method. For instance, you have a value, and I'm going to pretend I wrote private in front of that. So what you usually want to be able to write is invariant value greater 0, just as a trivial clean format. The problem is that it's not synchronized. So you have to write invariant synchronize this assert value greater 0. And then in the decrement, you do the in condition, etc. This is redundant with the body. Ignore that. This is just an example of an in condition. Usually check a parameter, of course. And again, you need to synchronize. And in the body, you need to synchronize the actual state change. And this still doesn't work. Let me be clear. This still doesn't work. The advantage of doing it this way is you don't get data corruption. That's all you're getting. You're not getting any sort of safety. You have a chance. You even have a good chance of catching invariant violations. If you only have one thread running at a time, you're still catching your invariant violations. But if you have two threads, you can check your invariant, and then you can check another method's invariant, and then you get into the body, and you've completely lost track of if your invariant is actually true. It's very hopeless. But the problem is, the advantage of doing it this way is you don't have to worry about shared. You don't have to do any weird casts. And it's very much a situation of pick your poison. And I think that the point of this is that we don't care about shared. We straight up don't care. We know we are in a class. We have private fields. We know these fields belong to us. We own that state. We own every method that mutates that state. We don't care about shared. We care about authority. We want to be able to say this is our data. This is owned. nobody from outside can write any data to it, but we can. This is not the same as immutable. It's not even the same as const. You want to be able to replace the data, but we want to be able to say we can only replace the data with data that in turn we own, and we can't hand it out. And at that point, if you're having a synchronized method, it doesn't need shared, because it knows that it's the only one that's writing the data. Just something to think about. That's where you want to be. That's not where D is at the moment. But it's something that we wish that would be kept in mind when thinking about the shared rewrite. So to summarize this, we are way below time. I've been talking way too fast. All right, whatever. You're gonna have a longer break. So in summary, at the protocol layer, you can take very much advantage of the fact that your model is transparent, your model is plain old data, it's readable. Everything on the protocol layer can be generated. Everything on the protocol layer can be swapped out. It's very nice. On the control layer, this is the layer where object orientation, process-based object orientation comes into play. You have a small number of points where you change state. You have functional algorithms, you have range-based algorithms, and you have very coarse state transitions. What I mean by coarse is that the state of your program changes in one go. You go from one valid state to another valid state. On the model layer, using declarative typing, what I mean by declarative is using these user-defined annotations. You're using read annotations, very, very, very seldom write annotations, and using invariants to guarantee that the state of your program matches what you're expecting from the domain, that you get an error if you try to construct anything invalid. So in the classic object-oriented sense, you have classes that model entities, that model relations between entities, and that manage the mutation of the entity. In object orientation, the state doesn't belong to anyone. The state is public. Then, sorry, I put that wrong. The data is public. The state is owned by the control class, and it is updated in the sense of the way in which it is updated. The methodology is decoupled from the actual state change. This is the range-based logic. And in summary, you get an object-oriented architecture. You use a very flat object orientation. You use declarative data types and use functional algorithms in order to improve your expressiveness. All right, that's it. Thank you. As a final page, we have I have a link up for the boilerplate generation for accessors, constructors, to string, etc. and structs. I have a link up for a dependency visualization and checking framework. And by the way, we are hiring developers. If you're willing to move to Munich, we're very much looking around for that. There. Thank you very much. Questions?
Yes, it looks like we've got 20 minutes for questions, so get asking, everyone.
I was just wondering why the control layer uses runtime polymorphism instead of compile time.
That's a very good question. I don't have a clean answer for that, but the background of this is that we've been somewhat tentative in introducing templates. Like, we originally started up in very much a Java framework, very much an object-oriented framework, and we have introduced templates in an isolated way. We've introduced templates to handle the modeling, the user-defined attributes. We've introduced templates to handle the protocol abstraction. We have not gotten around to thinking about templating at the control level yet. It's definitely a valid idea. It's going to make testing a slightly bit more difficult potentially, but it's definitely something that's possible.
Thanks.
I had a question about how the problems you ran into using garbage collection in classes. So
Yeah.
for those of us who haven't run into these problems yet, could you walk us through, like, what did you observe? How did you discover this problem? What should we be on the lookout for?
Right, that's a very good question. And that's something that I really should have used more time to explain in the actual talk. So basically, the problem was that we, as a company, very much grew into the level of data where we ran into trouble. Basically, originally when we started out, we did not have any difficulty. We had problems, we had processes maybe using a few hundred megabytes, and we were very happy like allocating everything, absolutely everything all the time. But then what happens is you deploy that code to production and you don't worry about it anymore. You just leave it running. There's no significant bugs. You may make a few fixes, but the code grows, it grows and it grows on. And at some point, you notice that your process has now run for 2 weeks and it's up to 2 gigabytes. And you still don't worry because it's normal. That's okay. You have the memory for that. The problem is that you never really notice a point where the memory use becomes obvious that your fundamental design pattern has been crippling. You don't run into a hard wall. You just run into, okay, maybe this is using a bit of memory. I should allocate more memory to the virtual machine. But the thing is, we could have from the start used ranges. But this is very much something that you're not going to run into if you are writing D in a way that isn't dogmatically focused on classes. Essentially, if you have a development methodology where you're already open to using ranges, where you're already open to using structs, where you're already willing to say everything that can be a struct will be made a struct, you're basically not going to run into that issue unless you actually have the amount of data to justify this amount of memory use. This is really something that we ran into because we decided that objects were fine. We can use objects all the time. It's okay. And then at some point, it became less and less okay as the amount of domain data we had to worry about grew, and as the amount of time that processes were running grew into days to weeks. So this is very much something that snuck up on us and that we only realized in hindsight.
On a related note, wasn't there an issue with a network interruption that was caused by GC collections?
I don't actually know that. It's unproven. Like we have an ongoing bug at the moment where we have some long-running tasks that you are now using WebSocket connections in order to deliver notifications, and sometimes, like maybe once a day, maybe we are running into connection losses essentially, and we don't know why that is. I actually know if this is the same problem if you're talking about, but it's definitely something that's affecting us acutely. And I think what may be happening is that we set the timer to 3 seconds, and you'd think 3 seconds is a lot. But if you're running 3 gigabytes of memory and you are under CPU load, and you're running on a virtualized machine where maybe other processes are also stealing a lot of CPU time from you, it is not automatically impossible to me that you can hit the timeout by sheer coincidence. You can just, your process can just go away for 3 seconds and not come back into user code until the time is already passed. I don't know if that's the case, but it's very much possible. So that, all I'm saying is give your networking code generous timeouts. It doesn't really hurt you.
You talked about that you were thinking about microservices for your architecture. Did you actually use that?
Yeah. From the start, we used a network of interacting services over network connections between Docker containers. And the way that this works out in practice is that we have a separate folder that is reserved to specifying interfaces, essentially. That is reserved for specifying state that needs to be shared between a service and things that talk to it. And this is actually handled by Git submodules, so you literally pull in that actual folder. It's convenient. Now, the point of that is that on the side that needs to talk to it, you really, on the protocol layer, you just instantiate you just instantiate a client. On the other side, you just instantiate a service. So this makes it very easy to bring up 2 services that need to talk to one another, can talk to one another in a straightforward way. And on the control layer, a REST call between 2 services looks exactly like a call between 2 domain slices. There's no practical difference. Now, where we started out was with a model of microservices that was a bit too big, where we had very, very monolithic, not exactly microservices, we basically had services. No way it's called micro. And we ran into difficulties with restarting them because we had a lot of active state in each of the services that needed to be restored on every restart. And that made our application very inflexible because it still takes a lot of time to bring those services up to an operational state. Now, we are trying to switch to proper microservices, but it is my impression that we may have gone slightly too far edging into nanoservice territory, which is very much unpleasant. And even with the small amount of boilerplate we still have a lot of infrastructural boilerplate to bring a new service up. And I think that does hurt us in that sense. So we're trying to find a happy medium there, but it's very much a transition in progress.
You said you had memory problems when you had your processes running for a long period of time. Did you actually identify whether that is simply that you're building up a lot of memory that you're using, or is this some problem with false pointers or leaks or something?
There are 2 separate issues that we ran into. The first one was an architectural one that we ran into with our XML modeling. Specifically, the issue was that every time we read an XML file, we wrote it into a class-based data structure where we had in each node of the XML tree a pointer to all children and a pointer to the parent. Now, yeah, those of you who know data structures in garbage collectors are realizing the problem now. And there are always going to be some false pointers in the program. The issue is with an architecture like that, with a tree layout like that, every single false pointer anywhere in your XML tree holds the entire tree alive. Everything connected to it, all the text data that you've just read, is everything, all of it is alive. That was painful. So a lot of that overhead went away when we switched to manually freeing every XML tree after we were done with it. But we could only do that because we didn't keep any XML state alive past the point where we had done the parsing. And this is another benefit of the separation between protocol and control. Because by the time you're done with your XML tree, you're done serializing it into your application, you are really done. You can very much be confident that all of that can be freed. And that is very much an advantage that we took advantage of to reduce memory use. A second problem that I'm not sure about, that was never properly debugged, but that I have my suspicions about, is D does not have precise stack scanning. It is going to take a while actually to get precise stack scanning. And I think the issue why we had false pointers, and again, this is a suspicion, this is not guaranteed. I think what happened is in a multi-threaded program, you have somewhere in your call tree, you have a pointer to your XML tree. And this is an address on the stack. And maybe that function returns, and then it calls another function, and that other function happens to be using a line data, for instance, and it has a hole in the stack frame at that point. So at that stage, your pointer is never going away while the second function is running, and that can be a very long-running function. It's just going to hang around literally forever, and it's going to keep everything in that XML tree alive forever. And at some point, maybe that function is going to return, maybe that field is going to be overwritten, but this is not something you can really count on. And D is not at the point where, if we had accurate heap scanning and if we had accurate stack scanning, that would not be an issue. And I think we would then be at a point where we could actually be confident that everything that can be freed will be freed, but D is not at the moment there yet.
I guess you could zero out.
Yeah, that's actually what we ended up doing
on the way out and see if it changes.
That is what we ended up doing, and that did help. The problem with that is that we didn't keeping that code because it is very much weird code and it's very much needs to be documented a lot. And we actually didn't end up needing it after we decided to manually free the XML tree at the point we were done with it. So, but it is very much something that we tried and that did help.
All right, we have a question from Discord here. Jinshil asks, how is Funk work managing language changes such as deprecations, and what is their feeling about gradual language changes?
I am so glad you asked. Okay, first of all, we are very much trying to keep our services at a level where everything is relatively current. We usually pick a compiler version. The last one was, I think, 282.1, where we're confident that we're going to take this version, we're going to stay at it for maybe half a year. And we're going to play around with newer versions if we need a specific newer feature. And we're going to try to get our library code up to date to the new versions as soon as possible. But generally, we're going to keep most of our services at a level, when we don't have a problem, we're going to keep it at the level and we're just going to keep going with it. But usually every half year or so, there's a service actually I've written for the company where, because every version is tracked and every version that we're pulling in is in a universal format. Like, for instance, we have DAP, or we have Git externals, or we have some other specification files that define how we are pulling in additional dependencies from the Artifactory, for instance. And all of those let us enumerate how many possible versions there are, what the current version is. So there's a page you can go to, and you can straight up look up what service is at what level of updatedness. You can see if a service is outdated because it's going to be marked in a very angry red. And it's basically going to tell you, the way that works is, whenever you're making a change to a service, that service moves to the top of the queue. So if you're looking at the front page of the service, you're going to see, all right, this, and this service has been recently changed, and it's very outdated. Maybe you should bring it up to date, hint, hint. And I think that we try to push developers to say, when you're making a change to the service, if it's not so outdated that bringing it up to date would be more painful than actually making the change. And that does definitely happen for very old services. But if it's not too outdated, the first thing you should do is bring everything up to the current standard, run the tests, see if everything works, and then do your actual domain task. So this is definitely something we're very aggressive about. About the second half of your question about language changes, we are hurt so much more by bad features than we are by changes. If there's something in the language that is hindering progress, that is causing ongoing bugs, please, for the love of God, change it, break our code. And we want you to break our code if it's in the interest of making the language better. Please, very much please. In my own interest, by the way, anytime you decide to remove alias get this and nullable, I will buy you a beer. I don't even drink beer, I will buy you one. That single bug has cost us so many hours. If you're ever worried about removing that because of legacy code, please, for our sake, don't.
So I see you used shared. Do you use it in production? And if it weren't there, would you be unhappy?
Are we using what, please?
Synchronized.
Oh, we're not using shared. We are very much avoiding the use of shared, primarily because we're scared of it.
I was speaking about synchronized.
Oh, yeah, synchronized in production. I'm sorry, could you repeat the second half of your question, please?
Do you use it in production? Question one. And will you be unhappy if it weren't there?
Shared and synchronized and specific. That's a hard question. We're using synchronized to the extent that we are basically using it as a wraparound mutex lock and mutex unlock. If it were not there, we would have to go back to explicit supertypes with automatic mutexes, which is something that I think with the proto object was already considered. And this is very much a transition that we would very much, not exactly like to make, but we would very much be open to making. And the problem with synchronized is that I'm not sure if a scope-based solution is more legible. Synchronized this in specific is a statement that you can very much see what it does. You can very much see what amount of code is covered by it. And if you're using a scope struct, for instance, a scope autolock, for instance, this would be more convenient to write in certain sense, but very much harder to understand. So I do think there's value in being able to write a declaration that just is to say this block of code is covered by a mutex. But that is not inherently something that needs to be in the language as a dedicated statement. I think, for instance, if there was a version of with that called a function on entry and called a function on exit, that would be very much an adequate replacement for us.
All right, are there any other questions? Nope, nothing. All right, then I guess that's everything. Give her a round of applause. All right, so we got about 15 minutes to the next talk now, so enjoy yourselves. And you go, excellent. And, turn around. All right, we're good to go again. Okay, just one little thing before we get going. I've had somebody ask for IRC and Discord details and all that. I will post those in the announce forum on the D-Lang forums. So if you want to get on and ask questions that way, I'm tracking Discord and IRC. So you just tag my nickname in there and I will ask questions for you during question time. Okay, with that out of the way, we can turn it over to Lewis. Talking about compile time types. Give him a round of applause.
Hi, thank you. Some of you already know me from previous years. This time I didn't have to come very far. Currently, I'm living in Cambridge. So if some of you are here in the UK or want to have a little nice trip, you may want to hang a bit. Drop me a line. I mean, to be cool to do some DSAF or other cool projects. Maybe I can provide even a place to stay for a few days or something like that. Okay, so today I'm going to be talking about compile time in D in general and how, in my opinion, it could be improved in some ways. And I think compile times could be perhaps be a solution for some of those areas for improvement. And this is still very early concept. So I'm prototyping some of these ideas, but I felt like perhaps it would be worth to present my initial direction. I felt like you could give me some feedback on this, but they are very speculative ideas. Still, It was kind of, to borrow a line from Linus, in the spirit of present early, present often kind of thing. So I really expect you to be very skeptical of what I'm about to present today. So it's me, it's not you. Your sanity is still there. But even though I expect heavy feedback, if you want to provide feedback and ideas and different approaches, that would be very welcome. So what's the issue? Have you heard about the Peter principle? Yeah, quite a few of you. The idea is that in an organization, you are promoted until you reach your level of incompetence. And this is a management concept, right, where you're like this really good employee and you're doing good work. It's like, yeah, let's promote you. And you keep doing good work and yeah, let's keep promoting you. And then suddenly you're in some kind of management position, don't really know what you're doing. And now you're stuck there because you're not going to be promoted, you're not going to be down-moted, whatever it's called. So you used to be such this nice and productive employee, and now you're stuck doing something you don't like, and nobody likes what you're doing. And this is kind of a metaphor that can be applied to a lot of things in life, and maybe even something like D. So D was introduced as kind of this alternative to C, and let's do kind of like a little thought experiment here. I want you to picture like a typical C code base. And it's a pretty reasonable language despite its flaws. I mean, some parts of it are pretty okay. The basic stuff like functions, structs, things like that. So there are some problems like with the types, undefined behavior and so on, but the basics are pretty reasonable. Certainly could be improved, and D improves on a lot of them, but it's pretty okay. But then there are other parts of C that are like a complete train wreck. And I just focus here on the preprocessor because it's like, I really hate it. Like headers, including them, the dependencies, all of their effects, having to define constants as like preprocessor defines and macros. It's like, man, that's like the worst idea ever. All of the problems that come with it, not respecting scoping, the unsafety of the lack of having to put parentheses around stuff. It's like completely brain dead. And when you use D as an alternative to that kind of C-like programming, where you use like C-style code, it's really nice because you take all of the bad parts, like you had to define constants, now you use like enum constants, you add like these ugly macros, you replace them with functions that can be inline, can be templates, so on. We have all of these nice modules, and it's really, really nice. We had these two disparate languages, the C preprocessor and the C language itself. You replace it with a much more cohesive whole. And the experience is, well, this meme, in my opinion, it was invented to describe the experience of programming in D in a C-like fashion. Sure, sometimes you'll have like vulnerabilities and so on, but it's just so pleasant to like, you hit enter, 100,000 lines of code get compiled in 1 second, and things just work. They are super simple because you write very straightforward code. It compiles super fast. You don't really use these very advanced concepts. So even a beginner can understand the code base. If you really have hard problems, you can just use a few of the more advanced features here and there. It's really, really nice. And I think sometimes it's nice to like just do that little experiment and do that kind of programming just to see the other side of life. But I feel it's really pleasant. Anyway, so this is so good, and this is like, oh, the good old times. You're like, what do you mean good old times? Like before we had anesthesia? Yeah, don't think about it too hard. See, if this is so good, then why rock the boat? It's because you don't really want to program in C, because you want these really nice features like ranges and introspection, generic algorithms, safety, no GC, immutable traits, all of this nice stuff. The problem is that sometimes that doesn't really work that well. And let me just clarify here. I imagine that I'd be presenting like to a very D-centric audience, but I know some of you guys here don't have too much experience with D. So this is all very relative. I mean, D on its worst day is still better than Java and that nonsense. So that's very relative. But you know, there are some problems. When you use some D features, the compilation can get really slow. You get these annoying error messages that are hard to understand. Sometimes you change one part of your program and something seemingly completely unrelated breaks the other sides. You have these weird features that you're not really sure how they should work and how they should interact with other features. And it's an experience that may not be the most pleasant. And that's like, well, yeah, D has been promoted to its level of incompetence. You were so happy using all of the basic features, and they work really well because there were these improvements upon C, like all of the bad stuff had been removed and replaced with something better. But you just had to open the box, and you just had to use all of the new features. But then you get stuck with some of these less well-defined behaviors and these not as pleasant programming experience. So why has this happened? Well, there's not one straightforward answer, but I think part of the problem is that D just has amassed a lot of features. And there's a lot of terrain to cover. Not all of the features interact with each other as well as they should. Not all of them are as well specified and implemented as they should. And there's always a lot of things to do into improving the language. And even features which sometimes in a fundamental way are just dealing with the same underlying concepts, they deal with them in different ways, so they kind of clash with each other. They have like different perspectives on how things should behave. Also, another thing that I believe sometimes happens is that when you program in this more modern D style, the way the D language works and the kind of approach we're trying to take, I feel that D, as it's currently defined, may not be have the most appropriate programming model for how we want to program. And what I mean here is that, well, I'll talk about that more in a minute. So I have this feeling that, like Strup said, like inside C++, there is this small, elegant language struggling to get out. So I ask you, is there like a more elegant language trying to come out of D, like this very beautiful core? And I believe there is, although in this talk I will focus more specifically on the compile time features. So how do we get to that essential core of the D language? I think there are two major ways of improving D. One of them is the way that's done most of the time, and it's a completely valid path, where it's this iterative model. Just pick parts of the language that could be improved in some way, don't have all of the nice properties that they should have, and you iterate on it. You provide a compatibility path so that you can keep using the old approach. You transition to the new approach, and here we have things like constructors, which you've seen talked about yesterday, things like the proto-object efforts. I think it's also a very nice work that's being done there. I think this is great, but for some of the more fundamental issues like this big language, maybe this isn't quite the right model for what we want to do. This may not be the most appropriate approach. And I believe the part here is that D is a really big language, but we don't have like a huge community. So it's not like we can unleash this legion of programmers and go like to these committees, specify all of the intricacies of the language like C++ does, like all of these proposals, and they battle it out, and then comes like a 1,000-page PDF that really specifies all of the different corner cases. I think our long-term strategy must be in terms of simplifying the language and finding common core features that we can build the other things upon. And so this is more like a research project, and I mean here research not necessarily in a sense of academic, but that my idea is that sometimes it's worth the effort to like do a little pause, think things from scratch, like not be necessarily concerned about compatibility in the long term, just explore an idea like if there were no compatibility objections, how would we really want to do this? And then once you explore that without having some kind of blinders on, you think, okay, I see here what's really fundamental. How can I then backport to the current production D? All right, so what should the core D features be? I think modern D revolves around a lot of compile time, and this is mostly two aspects. It's the introspection part, where you look at the code that's around you and you see what its properties are, and based on what you see, then you do code generation. So this is a bit like object-oriented frameworks, in the sense that you're no longer in control of like the main function. You generate code that will interact with this ecosystem. And you do something very similar, but like at compile time. And I feel it's very important that these kinds of activities, since they are so central to modern D, they should be very natural. They should feel like just regular programming for like runtime stuff. They should be very accessible to beginners and so on. So what is compile time? Well, it's not a single thing. I mean, there's a lot of different uses that we have for it. Some of them are computing stuff at compile time, so we don't have to compute it at runtime. Others are like metaprogramming, generating other programs, just choosing which parts of the program we are going to compile, which flags, things like that. And so we have very different uses for it, but in terms of also the implementation, they have very different implementations. And this often leads to a lot of accidental complexity, where the different parts, they don't really agree on a common model. There's this interesting article online on the D Wiki talking about compile time versus compile time, because especially new programmers indeed tend to have this idea of what compile time is. That's not quite correct. And you can see that indeed there are two fundamental compile time notions. There's a notion of the AST building level, which is like kind of the templates, the static if, and that kind of stuff. And then there's the compile time function execution. And the problem is that they are kind of disconnected, and sometimes people don't really realize that, which is something that this article addresses. You should totally read it. So the AST manipulation doesn't really have access to the complete semantics of the program, while the compile time function evaluation doesn't really have access to the AST manipulation. So they exist in completely different worlds, which explains why people will sometimes ask things like, why can't the compiler read this value at compile time, since it's clearly known at compile time value? So for instance, here we have this compile time function, and we have a static if, and we are looking at this b parameter, and we know that this b is true because there's this true value specified there at compile time, but this won't work, of course. And if you're familiar with the intricacies of these languages, it will be like totally obvious to you, and you're like, why is this even an issue? But the problem is that there's no clear mental model for someone who's just coming to this stuff. And it's very easy to, if you're already very familiar with D, to disregard this and think that that's not an issue at all. But I believe it is. I believe there's something fundamental here which is being confused. And there are sometimes examples which trip up even more experienced programmers. Like in this example, we have a function which receives this array of arguments, and you do a for each over them, you do a static if, and then you have the continue for the for each. And so you're thinking, what does this print?
All the times, and not an int every time.
What does it print, sorry?
Like not an int at every iteration.
It prints not an int on every iteration.
Yeah, and when it is an int, it also prints that this is an int.
Right. And this isn't super obvious to someone who's not, doesn't have a lot of D experience. So read the article if you don't understand why this is the case. Moving on to a different example, this should also be pretty easy to someone who just got started with D. So what does this print? Okay. Int function of int. It's pretty easy. What does it print now? Wow, I thought Attila would know this, be like, this is super trivial. I know. Yeah, it's not a function anymore. So it prints void, which I'm not even sure makes sense, because it's like void is a type. A template doesn't have a type. So it should just not print anything or give out an error. being strictly speaking correct about types, like type theory and that kind of stuff. So why does it print void? Well, because that part of the compiler doesn't know anything about templates. It doesn't see templates. But I think this is problematic because it's totally reasonable to think what the type of a template is. There's nothing fundamental about this decision of that part of the compiler not knowing about templates. So perhaps this is the design that we actually want. So what's a type? A type says useful things about our programs. It says what something represents, what its possible states are, and what operations you can do with it. So I ask you, is this something reasonable to ask about a template? No?
It has no type. The question doesn't make sense.
It has no type, but couldn't it have a type?
No. It has no data, it has no state, it has no operation. You can do on the runtime.
So the argument is it has no state, it has no operations that you can do with it. Well, I disagree. I think it has operations like you can instantiate. That's an operation. The type can tell to you what you need to instantiate it with. The type can tell you what do you get back because different templates return different things. Yeah.
For like a simple template with
For like simple implied templates like a class or a struct or a function, this what you're saying makes sense, but a template can also be like a block and you can define many things inside of it. Maybe I'm just not seeing what you're saying.
Yeah, I think the summary of the question is like, well, this is a really hard, tough issue because it's like a template could just return so many different things. It could be like a struct, but it could also be like a block, right? So how do you make sense of that? Well, that's why I say that this is very out there. It's like smoking a bit of weed, thinking what's really fundamental about this. But on the other hand, there's like so much potential. Maybe if we can answer some of these questions, then we can unleash all of these different potential that's there in the language.
Well, it's not really. I understand what you're saying, but templates aren't types. They're kinds, though. I mean, your example with foo was kinds, type to type. It takes a type and then it returns another type, which is a function.
So Attila basically is saying, you can't do it because I guess it's a function. Well, a function has a type, so I guess it kind of makes sense. It's a higher order type. So
yes.
So it's kind of a type. It's a different kind of type.
Yes.
It's a type of types. So higher order type, kind of function. So it turns out, well, it's like, doesn't make any sense. You start, but then you're like, well, it could be this, it could be that. Well, maybe it's worth thinking about it. So I could go away to right now. It's like success. I've got you started thinking about this. We already have some success. So still being on the wondering about these characteristics of templates, we have discussed what its type should be, although we haven't arrived at the conclusion yet. We can also wonder what exactly the semantics should be. And these are these areas of the language that aren't quite very well specified. So for instance, there are issues of when exactly is the template specified? So the issues of ordering, because a lot of the language is declarative, but then you instantiate templates in those declarative contexts. So what happens when you have things that you will be able to notice? Yeah.
When I was thinking of templates, I was thinking a little bit of like JavaScript closures. So if you have a template and define like 3 functions and a struct inside, in some ways, a template is kind of like a compile time environment in which you can define other things inside, like types. And you can have like a chain of nested environments that fully describe the type.
That's interesting. Yeah, I could see that. So it's a kind of compile time environment, something where at compile time you do stuff. And yeah, I think I could work with that. We'll get to that. If I don't address your issue, then please ask me again. I'll try to understand it better. So in cases where there will be side effects, we'll have to really be mindful of what the semantics of the ordering are. And also in terms of how many times a template is instantiated, what are the semantics that want to be there? Not what currently are in D, but in general, like the best possible world. D was designed from scratch with the best possible design. What would we really want it to be? And currently, we have this cookie cutter model where it's like this, I don't know, this kind of cookie shape, and then we create it several times. And this isn't really always the most appropriate model. And you can see, for instance, these with the typedef template, where you have to pass this cookie parameter. And this is kind of a hack, because it's like we say that if you instantiate a template multiple times with the same parameters, you'll get back always the same type. But then in other times, it's like, well, that's not really what I want. So I'll just pass another fake parameter just to disambiguate and say that I got back different types. But maybe that could be an opportunity to revisit, is this actually the semantics that we want from templates? Maybe we want to sometimes get different times even though we pass the same arguments. Back there?
I have worked with this problem a lot, and the thing is, templates do pretty much have to stay the way they are, but we could introduce another system that has more functionality that you want, that allows you to specify what types of type operations you can perform and stuff.
Okay, that sounds, let's talk about that. That sounds interesting. Okay, so what about the semantics of what you get back? I mean, you have, in a template, you generate stuff, like you don't return a value, right? But we often use templates to basically get a value back. So we want function like call and return. And so we have this so-called eponymous strip where you assign a member of the template, the name of the template. But this is just a symptom of the model just being broken in some way that doesn't really do what we want. So it got this kind of workaround. But we got so used to it, but we kind of forget this kind of, in a sense, ugly and very arbitrary. And it's interesting because this reminds me of another language where you assign something to the name of the function to set the return value. You know what that language is?
Basic.
Basic, right? Yeah, things like Visual Basic, things like that. And that's generally not considered to be like a super popular design decision, but we have basically the same thing here, right? And then every time we do one of these decisions, like, oh, it's really cool, we don't want to actually access a member of the template, we actually want to get just like the return value of the template. So we'll introduce this trick of the eponymous naming the member after the type, and that will totally work and solve the issue. But then we introduce all of these complexities, such as, well, what about the other members? Should they stay hidden, or do you want them to still be publicly accessible so that maybe that's useful in other types? So it's like, oh, well, I guess it's useful in some contexts. In other contexts, it's not useful. I don't really know. We punt on these decisions, and all of this garbage tends to accumulate. And they're not very significant by themselves. Then they all start interacting with each other and have this big ball of mud. So that's why I think it's important to really reevaluate these decisions. And there's other parts where the language interacts. So for instance, if we have a regular function bas, we can just call it bas, and we'll be implicitly calling it. But then with templates, even though they basically have the same model of you're just calling it, getting the value, you still have to, even if it doesn't have any arguments, you still have to put the what's it called, that bang and the parentheses. So this is completely arbitrary. I'm sure there's a good reason for the way the parse and things work currently, but fundamental, these kinds of decisions are arbitrary, and all of this complexity tends to accumulate, and it trips up beginners and interacts in bad ways. Then there's, in terms still of thinking about what compile time means, there's CTFE. Who here knows what CTFE means? What does it mean? Come on, it's easy.
Well, execute an expression at compile time by compiling its pieces if they're missing.
Yeah, yeah. And what does the acronym mean?
Compile time function execution.
Everybody agrees with that? Yeah. I don't know. Half of the times it says compile time function evaluation. And I've seen lots of people argument that it should be evaluation because it's just a generalization of a constant folding and so on. And while the official spec says this compile time function execution, but you'll see all of these different nomenclature everywhere. So you can't even agree on what some of the most basilar fundamental building blocks of modern D are called. I agree with you, it should be called compile time execution. I don't think we even have to focus on the function because in some contexts you don't have to involve functions. There's also the issue of what should be CTF-feable, what should be executable at compile time. And I don't think currently there's really a good specification level rule for that, something that very clearly defines that. But it should be something where if I ask you, there should be like, oh, it's total, there's that rule, and I know if I apply that rule, I'll be able to answer that. I don't think that exists at the moment. So that's another area for improvement. So once we have all of these different differences, they tend to compound. So one thing that I really like about the more modern versions of the modern, talking about like last quite a few years, compare like D1 and early versions, is we have this unified function calling syntax where we can replace these very inconvenient chains of function and algorithms executions with this flow that much more clearly represents how the data is being transformed step by step. So you transform from the top there syntax to the bottom one. But then, of course, this doesn't really work with templates. Attila has this interesting article about what he got wrong. He has some examples there about some ways where you would want to use this with templates, but UFC doesn't really work there. You can look at the article to look at it into more detail, but basically this is kind of like what you have to write, and this is what you would like to write instead using the UFC syntax. And in this example, you still have to like factor out like these functions that you're calling at compile time, but actually argue that we should also, for instance, be able to use lambdas with templates. And so this is just another example of all of these arbitrary differences because some things are work with regular code, some things don't work with templates. We have these two separate universes inside of Team. Another example would be function arguments, where you want to pass a function to another function, like first-order functions, first-class functions. And if you are passing like a function at runtime, you have to use the ampersand syntax, while if you are passing it to a template, you don't have to use it. And then, of course, these will compound with things like if then you specify, it'd be great to have like a property-like behavior where you don't actually need to put the parentheses to call it. Then suddenly this works with one of the syntaxes, doesn't work with the other, and so on. I believe that one of the strengths of D is its plasticity. It depends a bit on how you use it. But for instance, here in this example, I have defined a struct foo, and I'm accessing a member of foo, x. So I write f.x. But then suddenly it's like, I don't really want the value of x. I want something a bit different. So I want to create this kind of indirection layer, but maybe I just want to prototype some idea really quickly. So I don't want to be having to change f.x everywhere. And this is the kind of changes that are really easy to do with D, because you just hide the original x, and you introduce these member x methods, and you still just call it f.x, and now it calls the function instead of directly accessing the member. And so it's super plastic D. And this is really convenient, being able to do these changes. You can quickly prototype a lot of changes without a lot of trouble. But then, of course, it's just one of those examples where this doesn't really work with templates. Let me see the slides here. So, I think I got a problem here with my slides. Anyway, here in this example, I'm passing two runtime variables to a function, and suddenly I decide I want to change one of those variables. So instead of being a runtime value, just being a compile time value, so I changed the y from being an int to being an enum, and suddenly on my call side to the foo function, where I used to just call it x colon y, now I have to pass it with the compile time arguments and the runtime arguments, at least if I want to preserve the compile timeness of the member y. In some cases, you do want to do that. So unlike the previous example where we were able to do this transformation without really affecting the rest of the code base, here, if I wanted to preserve this compile timeness, we have to change the call sites. And this is an issue that does arrive in practice as being problematic. And I found it interesting that this was one case where maybe not C the language, but at least GCC was actually better than D. In GCC, you have this magic called built-in constant P. So for instance, here I have this function, this C function bar, it takes a runtime argument, X, but I can, even though it's not declared as like a compile time variable, I can actually ask the compile, do you really know what the value of this X is going to be? And based on that, I can actually make some different decisions. And this is just a nonsensical example that I came up. So it's like, it's not supposed to make a lot of sense. Examples are like, what's the point of this? How would this be useful in any way? The example where I found this in the real world is for an SDK of a chip where you wanted to write some control register of that chip, and you just wanted to write in your code, write to that control register, that specific register, this value. And this was a preprocessor macro where it asks, well, if I know the value at compile time, then I can use the good encoding of the CSR instruction where I encode the immediate inside the instruction itself. And if I don't know it, then I'll just have to pass it on a register. So you are able to optimize your code based on asking the compiler, do I actually know what compile time, what this value is going to be, even though I'm using a syntax which it looks like this is just a regular runtime argument. And that's kind of the point. It's like, for users, this just looks like a regular function, so they don't have to think about all of this magic. But it's also that it interacts well with your environment, because if suddenly that 7 was coming from some other header, and it turns out it's no longer something that's defined at compile time, you don't have to change the function between, write DCSR with some value I know at compile time, or write DCSR with some value that I don't know at compile time. So you automatically get the best behavior based on what parameter you're actually passing it to. You could also see these with examples like formatting functions, things like that. So here I have my formats. You pass it a format string and the value that you're going to put it on your format string. So the case where you don't know anything about those arguments, you just call it normally, right? But then there could be other cases where you know the format string, but the argument of how you're going to put the integer value there is going to come at runtime. And there's also the case where you know both of them at compile time. And you want to have like this uniform syntax for those, but then take advantage of the knowledge there and optimize based on that. And that's something that was introduced not that long ago in Phobos, the standard library, with the right formatted writeFLN function, where now you have the possibility of passing the format string at compile time. But then this was an intrusive change. You have to actually go to your code base, change all of your format strings to be passed as compile time argument. So you don't have the benefit of just, even though the knowledge is already there for the compiler, you can just say, please do take advantage of the knowledge. So you have to change all of the call sites. And it's not very obvious how, in general, if you are using this in generic code, how you don't take advantage of this without creating a big mess. And notice that even now, even though you're taking advantage of knowing the format string at compile time, you're not taking advantage of knowing the other arguments at compile time. So you can't like actually know, oh, I know the format string and the arguments. Let me just pre-compute the old string at compile time, and then I don't have to actually do any work at runtime. So it just kind of proves that you really have to, as it currently is D, do a lot of work to take advantage of these properties, and this is like not the best possible model. Let's skip this. Okay, so let's talk about what I think could be an alternative approach. But before that, let me just ask you. So one way to look at it is like saying, that's just how D works. You're talking nonsense. You're talking like properties of templates, and that doesn't even make any sense. So just don't do anything. Another way, it's like, okay, I could see that there are some inconsistencies here and there. Maybe those could be improved. And you go over each one of them. You try to make them a little bit more consistent, to work better with each other. But that's going to be a lot of work. And it's very easy for different differences to leak out and become visible. And you have to maintain all of this parallel infrastructure. Another possible idea would be to really build some kind of common building block, some kind of infrastructure where you can then build the more advanced features on top of. So that would be solution 2 and kind of what I'm talking about here. So what's the type of this? Int, yeah. Pretty simple. What's the DMD output for this? Compiler error, yeah. It's like, yeah, you can't modify constant expression X. So you have a type that says, well, this is an int, but you can't modify it. As easy as it goes. So what's the type of this? Int. What's the DMD output of this?
I cannot assign to our value or something.
Cannot assign to our value something like that. It doesn't really matter. It's cannot modify constant X. The other one is cannot modify constant expression X. This is one cannot modify constant X. I don't know why one focus on the expression, why one focus on the variable. Seems arbitrary difference. I would say the enum one is the one who should focus on expression. But on the enum, the type of the variable is int. So one way of looking at it is like, well, you're giving me the properties of this variable and what it should do, what you can do with it, what you can't do with it. But the int doesn't encode the constants that you can't modify it. And also, it doesn't encode the compile timeness. So there's this mismatch where the type system isn't really working for us. We have to keep this parallel notion of what we can do with types, while in many places it would be much more convenient to just have those notions encoded as part of the type. So how do we add to that enum X that we want to have at the level of the type system some notion of compileness? Compile timeness. Well, we could add some kind of compile time qualifier to the type to say this isn't just an int, this is a compile time int. So what kind of qualifier? What do you think of this proposal? Compile time int X. Is that like a great syntax or not? No, come on, this is great syntax. I'm sure Walter would love this. What about comp time int? I don't know why you're complaining that much, because this fits pretty well with Indeed. It's like C++, there's like the ampersand. We have ref. It's like it's more verbose, more explicit. We have immutable. Why don't you like comp time or compile time? It's like immutable. It's like a really long keywords. So I actually think this is pretty reasonable. But if you don't like it, I guess we could go for something a bit shorter, like, for instance, like some kind of pound or something like that. It's like compile time int. So Now you're going to read this every time you see like the pound, you're going to read it as compile time. So what's the type of X? It's a compile time int. So how do you declare that enum variable? Well, it's not really a compile time int, because a compile time int would be something that would be modified. So then you need to also include in the type some notion of constants, right? So probably either a compile time constant int or a compile time immutable int, something like that. Immutable, as the advantage, is kind of long keyword. But I think it's the one that generalizes better from the notion of int.
We could reuse the static keyword.
Yeah, it's really an overloaded keyword. Static int. Wow. Okay. So now we can have things that you used to not be able to have, like you can now have module level ints that are mutable. So for instance, you could declare a container where I'm going to gather the names of all the things I use, and then you get, for instance, compile time reference to something, which is like an alias, and you get the properties of that, and you mutate it. So you have all of these different approaches where we just broke these completely different worlds that you used to have between the EST and the compile time function execution. In terms of compile time statements, how could this work? Well, you could prefix them with the pound to make them be executed at compile time. So for instance, a static if would be a pound if condition. And I'm not sure here, perhaps also dynamically based on the time of the condition, if it's declared as a compile time condition or runtime, it would have different behavior. Then you need to worry about the scopes introduced by the braces. So currently, this is very contextual. If you have a static int, the braces don't really include a new scope. There are several different approaches that you could handle that. I'm going to skip over that. What about function templates? Well, used to have all of these separate compile time parameters and the runtime parameters. You could integrate them. So it's like now we'd really have an uniform function calling syntax. And one of the advantages of that you can change their types and you don't have to shuffle around. So for instance, if B transitions to a compile time B, you don't have to shuffle their order around. And now we are ready to answer what's the type of a template. It's not template, it's not void. It's, as some of you were saying, it's a kind of compile time function, right? Something you do at compile time where you can generate this code, return these values. And so the exact type would depend on what arguments it receives and what it returns. So for instance, it could be a compile time function that receives a compile time int and returns a compile time int. Then you have to answer how would this approach be able to do things like declare struts. So the hard way to do it in the old way be where you have a template. I think the equivalent way here is that you have a compile time function that receives a compile time integer argument, and then you return the type itself. So you need to have first class types. A question there?
Well, this one doesn't work either. Oh, here we go. We've got volume.
Okay, now it works. That is something the parameterizing compile time type does not work, because then the is breaks. So the reason we have the hash tables for templates is because there are actually fundamental principles in the type system that do rely on the same template being instantiated with the same parameters, resulting in the same type, and we cannot break that. That the one that you have there right now cannot work that way. You would have to wrap it in the template.
Yeah, I get what you're saying. I think that there are a lot of challenges with this, so that's why this is very exploratory. And I'm aware of that issue of things being able to return different, with the same arguments, return different things. So that's like, if you have a non-pure compile time function, that could impact type equality. It's basically what we're saying, right? So that's an issue. I'm completely aware of that, but I think there are solutions for that. Let me just speed up a little bit to not take too much of the time. What about other compile time types? So first class types have types themselves. So where you'd have a compile time type here, I guess the equivalent would be that you receive some t, which is itself of type, except that type is a compile time type. And that's here, perhaps in some cases you'd want to integrate the notion of type off and runtime type information. That has some pros and cons. Another issue is that how this would work in terms of type deduction, where you pass in the template parameters the t, and then you deduce it based on the calling site. There are several possibilities for how this could work. For instance, in Sparrow, it has the any type, so this is kind of a wildcard. In Jai, it has the dollar syntax, where you mark from which parameters you want to deduce it. There are different approaches, like for instance, you could receive optional arguments that you don't have to explicitly pass, and those could interact with the other ones. But depending on how you want to do that, then we might have to relax the rules for passing optional arguments in different parts of the calling order. Another issue, of course, that if you start putting compile time this and that, suddenly you have like compile time everywhere. So you're putting these hashes everywhere. That gets old really, really fast. An issue where if you just want to do like CTFE type computation, you could just mark a function as being compile time, and you wouldn't have to like declare every argument and every variable and every statement as being compile time. And that would just get lowered by applying the compile time notion to each one of those. And I think this part here also helps to answer what makes something compile time executable, where first you want to get a function that was just a regular function, you apply the compile time modifier to it, you recursively apply the compile timeness to every part of it, like every statement, and then do type checking on that and see if that is able to be compiled and run. And for calling runtime functions, doing that lowering, you'd use the pound syntax. I'm going to skip a little bit more. So one advantage of this approach is that you could get a lot of features that are currently separate features and just use these compile time functions to do the same thing. So why do we need to have a pragma message? You could just have some kind of function that at compile time outputs a value. When we read files with this special import statement, we could just have a compile time function to read files from the file system with security concerns, of course. I don't think we really need to have all of these great syntax, not all of them, when you could just have a much more clear compile time API, where it just be just another API, except that the functions are compile time functions. And I see a lot of uses of string mix-ins, where you create all of these arbitrary coded compile time, that a lot of them I think could be a lot more clear if you just had a much more contained API which did much more specific things. You wouldn't have too much flexibility. So here in this example, instead of manually doing the parent dot the member, you could just call the compile time function get member from a reference to the parent with the name of the member name, and it would do the same thing as that string mix-in. I'm not sure where, I don't think there's any language that explores quite this region of the design space. So for instance, I borrowed some of the ideas from other languages, and you can see that they try to address similar things, but they don't really go there to the same territory. So yeah, I know this was very speculative. I'm totally sure almost none of you were convinced by it, but I feel there's like this core of a potential there. So I think could be further worked upon, massaged, and maybe even if it were not applied directly to D as it currently exists, some good ideas could be ported back. So I'm still playing with these, and if you have, like I saw before, some good ideas that you can share with me, try to see if we can make some progress of these. Your feedback would be totally welcome. So thank you.
All right, and it's question time now.
One thing I didn't see you mention that hits me a lot of the time is __ CTFE. Because sometimes I write a function, especially for mixins, that is only ever called a compile time, and then the compiler complains if I'm using a runtime parameter at compile time, saying, I can't read this at compile time. Yes, you can. I'm only calling it from CTFE. So, yeah, I don't know what you think about that.
It's interesting. I'm not sure I actually did think about that, but that does sound like something that you really want to have like a test case for that to see if the design solves that. So I couldn't list it all, but I had this huge list of different, and I want to make sure it works in this case. I want to make sure it works on that case. But they were it was such a laundry list of little issues that I couldn't really put them in the presentation. But I have a long list of that kinds of issues. So if you can share your concerns with me, maybe I could make the list better cover of the concerns. And yeah, so that's a like very, very valid point.
Yeah, I think we in particular have a lot of the same work that we did. For example, I wanted to do the same thing you did, but except I didn't use the hash. I did use I repurposed the alias keyword because that already expresses that something is a type or that something is only known at compile time. And we should definitely talk about this together. Thank you very much for bringing more attention to this. I'm very happy with this talk.
Yeah, thanks.
All right, are there any other questions here? Manu?
I'd just like to share an anecdote that I had. I recently did a hackathon in the office where one of my colleagues was exposed to D for the very first time. Going into D, he was very happy with it. He did a whole bunch of meta and complained bitterly for days about all of the things that you discussed in the start of his talk. And then his takeaway from D was, yeah, I kind of like D, except I wish it was pretty much the way that you've described.
Wow, but that's like the best compliment I could get on that. Yeah, that's wow. Thank you for sharing that anecdote.
All right, any more questions or anecdotes? No, looks like we're done. Thank you again, Luis.
Thank you.
All right, you know what happens when the big hand meets the little hand up there? It's 12 o'clock and it's lunchtime. So back here in an hour and a half for our keynotes talk.